The factor theorem for polynomials. If p of x is a polynomial of degree n greater than equal 1 and a is in a real number, then number 1, x minus a is a factor of p of x if p of a equal to 0, and p of a is 0 if x minus a is a factor of p of x. This factor theorem is just an extension of the remainder theorem. What you have learned in the remainder theorem, if p of x is a polynomial and it is divided by x minus a, then p of a is the remainder. Okay, once again, if p of x is a polynomial and it is divided by x minus a, like this. If p of x is a polynomial, you see here, if p of x is a polynomial and it is divided by x minus a, then the factor remainder theorem says the remainder is p of a. So the remainder was p of a directly by using the remainder theorem. Now, if this remainder is 0, when remainder 0, I explained already, if the remainder is 0, then the divisor is a factor of the dividend, or the dividend is a multiple of the divisor. So if our remainder p of a is 0, then p of x is a multiple of x minus a, or we say x minus a is a factor of p of x. This is what we are going to do here in the questions you see. Okay, now if p of a is 0, if the remainder p of a is 0, then what I said, x minus a is a factor. This line, x minus a is a factor if p of a is 0. Converse, if x minus a is a factor, if it is a factor, there will not be, it will be exactly divisible. If x minus a is a factor, then p of x will be exactly divisible. Exactly divisible means the remainder is 0. So p of a is 0 if x minus a is a factor. That means whatever the remainder theorem we got it, where p of a is the remainder of we get after division, that remainder if it is 0, x minus a is a factor. Converse, p of a is 0, then x minus a is a factor. X minus a is a factor, then p of a is 0. So I just give an example, then to be clear. So, supposing p of x is a polynomial x cube minus 1, and you have to check this x minus 1 is a factor or not. So it is very simple. We will get the particular value of x, like a here, from the divisor, because we have to check x minus 1 is a factor or not. So this x minus 1 is a divisor. So what we'll do, we'll get the value of x, like this value a, from this divisor, the linear polynomial. Okay, so what we do for that, let x minus 1 equal to 0. This implies, simplify it, x equal to 1. So this is the particular value of x which to be replaced here. Like if a, then we replace p of a, then we get x we replace by a, p of a. So similarly, x equal to 1, so this x to be replaced by p of 1. X to be replaced by 1, so it will be p of 1 equal to x cube means 1 cube minus 1. X is replaced by 1. 1 cube is 1, 1 minus 1 equal to 0. Now see, you got p of 1 is 0. If p of 1 is 0, if you get this p of 1 0, we say x minus 1 is a factor of p of x. Therefore, x minus 1 is a factor of p of x. Now if you get this number, which if you get here is a non-zero number which is not equal to 0, you will say x minus 1 is not a factor of p of x. Okay.